My project is inspired by the instantaneous nature in the body movement. Like some of the scholars say, dance as a performance art always lives in the passing moments. The repetition of the performance is never gonna be the same. But the problem is the form and energy expressed through each performance can be subtly different. Therefore, it's hard to capture the dynamics or the feeling dimension of the movement. I worked with a friend who dances Chinese folk dance. She prepares a 20-second dance and moves in repetition. I attach 2 accelerometer sensors, each to her arm, and have her one hand hold the microcontroller, which communicates to the computer wirelessly through a Bluetooth. 3 types of data are acquired. To translate from the data to shape to represent the dynamics of the movement, I built on the movement schema developed by Hansen and Morrison to interpret the data. Velocity, position, repetition, and frequency are identified as the 4 movement qualities in their movement schema. I mapped each of these 4 movement qualities to what shapes to represent and what register data to use. I went through multiple rounds of the iterations to generate the 3D design in describing the movement dynamics. The basic logic is the discrete aggregation, that is, multiple unit geometries transformed and aggregated based on the meaning of the corresponding digital data acquired from the dancer. With the 3 types of the data obtained from the movement, the transformation of each unit shape forms the relationship to the previous one in terms of the change of the location, the size, and the orientation. I started with the ellipse as the building block and the circular trail as the movement flow. Since the transformation of the 2D shape limits the full use of the data, this leads to the second iteration by replacing the 2D ellipse with the skeleton-like 3D shape to resemble the transformation of the body. This allows the flexibility of attaching multiple sensors on different parts of the body and also more effectively illustrate how body movement transforms discretely in shape properties when they are aggregated along the movement flow. Although the circular form is good to indicate the animation circle, it doesn't really show the movement flow in space. This leads to the last iteration to add spatial information to the design. Building on LeBon's idea of kinesphere, dancer always moves within a bounding space oriented around her own body. So I continue to work with box as a space and forms a curve by connecting the randomly generated points on the surfaces. A variety of spatial curves can be generated by tracking the primary locations in space where the dancer passes by. By aggregating the unit 3D geometry along the spatial curve, we can further generate different variants of the design. In the end, I present the 3D printed designs to my dancer for her feedback.